Hello, I am Deepak. I am from Reliant Institute of Oil and Gas. I am a trainer here. So today I am going to show you the demonstration of magnetic particle inspection. So I am going to conduct magnetic particle testing and then I am going to evaluate the result, and I will be sharing some information related to the MPI, magnetic particle inspection. So in MPT, magnetic particle testing, so as we know, the basic principle of magnetic particle testing is magnetic flux leakage test and visual test combination. So the combination of magnetic flux leakage testing and visual inspection with the help of magnetic particle. So in this test there are basically two methods. One is visible technique and fluorescent technique. So visible technique will be done in the presence of white light or daylight, and in the case of fluorescent technique it will be done in the dark room, and the indications are viewed with the help of black light or UV light. It is also called as a UV light. UV light is also called as a black light. So now before starting the inspection, now I am conducting visible technique of magnetic particle testing, and I should make sure that there is a adequate lighting for conducting this testing. So since it is being white light and combination of white light plus daylight, so I want to check while performing the testing on this specimen, so whether the adequate lighting, so as per the BS and EN ISO, it is around 350 lux to 500 lux, and according to American Welding Society it should be more than 1000 lux, precisely 1076 lux. So in my opinion, basically if it is more than 500 lux, way to go for conducting the testing. So I am using a lux meter to measure the illumination. So I am keeping the lux meter on the test specimen where I am going to conduct, and I am switching it on. So I can able to see almost 693. I am holding the value. So I can show you that it is around 662 lux, so which is very sufficient to conduct the magnetic particle inspection, and also for visual it is more than sufficient. So now there are different methods of magnetization in the MPI, like we have a coil method, we have a headshot method, we have a prod method, we have a yoke method. So today I am going to show you with the help of yoke method or yoke machine, by using the yoke machine. So there are two types of yokes, permanent magnetic yoke and electromagnetic yoke. So today I am going to conduct this test using this yoke. This is the electromagnetic yoke, and it is also having the two options, AC and DC option. So before conducting the test, so if it is in the site, we have to make sure perform the yoke calibration. So what is yoke calibration? So we are making sure that the yoke machine is perfectly able to conduct or magnetize the object for better magnetization, and also to get more indications. So in yoke calibration, two types are there. So we are having AC and DC. So if we are switching it to AC, then the yoke should have a capacity to lift 4.5 kg. So if I am switching it to DC, which is having a more penetration and more depth, subsurface level we can identify. In the case of AC, only surface or just near surface we can identify. Then in the case of DC, it should lift around 18.3 kg. So this is what we call it as a yoke calibration, and I assure you that already the yoke is calibrated before performing this video. And I am using a pi gauge. So this is called as a pi gauge. So this pi gauge is kept between the legs of yoke, and make sure the flux is passing in between the legs, magnetic flux. Then this is the ASTM block. This also can be used to see, the different holes are made at different depths, and we can also check whether the yoke is capable of identifying these side drilled holes. So I am also using a vernier caliper to measure the dimension of the defect, and for emergency case I am using a magnifier to make sure any minute indications to be identified. So in this method, first the surface has to be cleaned, so pre-cleaning has to be done. Then next is magnetization using the yoke machine. At the same time, simultaneously I will be using a magnetic medium or magnetic particle, wet method. So the particle is mixed already with the oil, and this is a ready-made mixed proportion. So I'm using this 7HF magnetic medium, wet medium, to make sure the indications are available. So let us start the test. So first, as usual, I am cleaning the surface with the solvent. So I am using a solvent cleaning method. Already the rust and other things are removed. So like in a penetrant testing, in magnetic particle testing, it is not necessary or no need to worry about filing, grinding or anything. Even the MPT is able to be done on the painted objects. So minimal cleaning is sufficient. So I have cleaned already this specimen, and now I am also using a pipe. So this is a butt welded plate and this is butt welded pipe. So I have done a minimal cleaning which is necessary. Now I have to apply white contrast paint. So the white contrast paint is applied to give a contrast background, because the magnetic medium is black in color, and which will be very difficult for the inspector to identify the indication if we are conducting the test without giving a contrast background. So first I am applying the white contrast. So this has to be shaken well before applying. So like in a penetrant testing, as I applied before, here also the white contrast has to be applied 1 feet distance. So I am going to apply the white contrast paint. So I am making a test shot. So you can see here. So this white contrast paint is giving a contrast background for identifying the So now I have applied the enough amount of white contrast. Let us wait for at least a minute to get it dry. So now, before conducting the testing, I should also check the yoke with the help of pi gauge. So this is the pi gauge. So it will be having a disc will be having a two faces. One face will be having a lines. In other face there will be plane surface will be there. So I have to make sure the pi gauge should be kept on the test specimen in between the legs and when I apply the magnetic particle, it will show the lines. That confirms the magnetic flux is traveling in between the legs. So I am applying this now. So you can hear the vibration because of AC. So in DC you cannot hear the vibration, but you can see the magnetic field is very strong. But in AC, due to skin effect, the sound will be there. So only surface defects is very clear. But if you want to go little bit higher, like up to 6 mm, you need to switch on to the DC mode. Check with the help of black medium or magnetic medium. So it is a ready-made magnetic medium available. So this is 7HF. So as per ASME section 5, then even ISO 9934, BSEN 9934 sensitivity level 2. So I'm shaking it. So I'm applying the magnetic field. So I have placed the the pi gauge in between the legs. Now I'm applying the magnetic particle. You can see a line forming. So you can see in the plane surface, we can see a lines formed. So that confirms the magnetic flux is traveling in between the two legs. So with this, now I am conducting the test. So I am going with this area. So we have to place in 90 degree, then we have to shift the placement to 45 degree in order to capture longitudinal defect and transverse defect. So now we are getting an indication crack here. So we can able to see a crack very clearly here, a branched crack. So you can see here a branched crack. So in order to get a clear profile, and also you can see a parent metal crack here. I will just try to get it back again. So now when you see here, you can see a crack very clearly formed at the heat affected zone just adjacent to the weld. So parent metal longitudinal, parent metal heat affected zone crack, and this is longitudinal. Sometimes we can also call it as a branch crack. Let us see one more time. So it's very clear that a branching crack is arised. So we got two indication, one in the parent metal, another one in the weld metal. So one parent metal longitudinal crack, another one is longitudinal branched weld metal crack. So now in the case of a pipe, now I'm going to conduct the testing. Now the testing is over on the plate, butt welded plate. Now I'm going to conduct the testing on the butt welded pipe. So before that, let us measure how much length of the crack. So the crack length is coming around approximately 28 mm, and this is approximately 26 mm. So we have to make sure, mark the area and ask the we have to take a photograph, then we have to inform all the details of test specimen and other information in the report, and then we have to submit for the repair work. So now I'm keeping this plate aside, and now I'm performing the magnetic particle testing on the pipe. So I'm going to conduct the testing on the pipe, but there is a small assistance is required because I'll be holding the machine like this. So I need a small assistant from the professional. So sir, you can hold this. So just apply it. Okay. So beautifully an indication has developed here. So I can show that here a toe cracks radiated to the weld material. So here there is a 2 cracks available from the bottom plate and the top plate. Now I am continuing. Sir. Sir. Yep. So here we have a better indication. Yes. So you can see here a branched crack from here and from here and from the bottom it is connecting. Just see the beautiful indications we got. So before 2 cracks we found in the bottom plate and the top plate, then now we can see a branched crack in between the 2 plates, and we are going to check some more further. So let us check in this area. Sir. Okay. So there is no indication. So we finalize with this. Here 2 cracks and here a branched crack. So this concludes the testing, and since we got a crack as an indication, so primarily it has to be rejected first, then it has to apply for a repair work. Once the repair is completed, again we have to conduct the testing and make sure the defect is not available. So finally I want to show you with the ASTM block. So this is the ASTM block. So this will be having holes, sidral holes at different depths. So I want to make sure how it is showing. So I'm keeping here, I'm giving a gap. applying the magnetic field. So now I'm applying the magnetic medium. So now see here, only one line is visible. Why? Because maximum in the case of AC we can identify only the surface and near surface up to 2 mm. But if I want to get some more indication, I am switching it to DC. Now with the DC I am applying, see DC I have applied, there will not be any vibration with the DC, but see, based on the depth of the defect, we have 1, 2, 3, 4, 5, 6 indications we got. So this is near surface somewhat more than 2 mm, then almost 3, then 3 to 5, 3 to 6. So up to 6 mm we got indication, but this is, we need some more experience to clearly locate the defect, but this is also a defect. But the depth is some more is there, that's why. So based on the penetration level, the indications will be created. So this I just conducted to show you the difference between the AC and DC. So in AC, maximum surface to 2 mm practically, then with the case of DC 2 to 6 mm we can identify the defects. So this concludes the magnetic particle testing, but now still we have conducted only the testing. Once we take a photograph of these defects, then we are reporting it in the report sheet. Then finally it concludes the inspection, because inspection means testing plus evaluation, whether to accept, repair or reject. So now finally the testing is over, I have to do the post cleaning. So thank you very much for patiently watching this MPT, and if you have further doubts in theoretical section, please contact us, and you can also join our online or offline classes.